if we do the same thing we did for an ellipse, but specify that instead of the sum, it's the difference between the two distances, d2 and d1, from the foci that's constant. That is, again, we set up negative c0 and c0 on the x-axis, for example, and specify that the difference, d2 minus d1, the distance from the left focus, the difference of the distance from the left focus and the distance from the right focus is constant. Then we don't get an ellipse. That's what you get if you add the distances and it's constant. If the difference of the distances is constant, then you end up with an equation possibly like this or possibly like this, depending on which distance is 1 and which distance is 2, and depending also on what your constant is. Okay? Now, if you end up with this equation, and you end up with the equation just by going through the same kind of algebra details we did the first time we did an ellipse. Okay? Everything, you have to square the thing twice, and when you run through all the steps, if you write down this condition properly and correctly, you'll end up with either this or this. If you end up with this, then you get the blue hyperbola here. If you end up with this, you end up with the red hyperbola. Now let's see what the difference is between this, and let's think about what this rectangle is doing down here in the middle. This is the same rectangle that you would have drawn for an ellipse that had an A under the X and a B under the Y. You come out A units this way and B units this way, and of course A units in this direction and B units in this direction. Everything is symmetric with respect to the origin. Then you draw the diagonal lines through the corners of that rectangle. When you construct the hyperbola, because this is what it's called, it's a hyperbola, you start at the vertex here, A0 or negative A0 if you're drawing this one, and you draw this hyperbola-shaped curve that comes out and approaches the diagonal line as an asymptote here and here. It's going to approach closer and closer to this line on this side and closer to this line on this side. Same thing over here. If you have this hyperbola, then you start with the point 0b or 0 negative b and come out again asymptotic to the two diagonals. Now how do you tell which is which? Let's think about it for a minute. If you've got x squared over a squared minus y squared over b squared equals 1, let's ask, is it possible for x to equal 0? Well, if x is 0, then this term is 0, and we have negative y squared over b squared equals 1. Y squared is positive, b squared is positive, so that this thing is negative because of the negative sign. Can a negative number ever equal 1? No. So if it was possible to get a point xy satisfying this equation such that x was 0, you'd have a contradiction. You'd have a negative equal to 1, and it can't be. So that there's no xy that satisfies this equation for which x equals 0. Now, which hyperbola here doesn't have an x equals 0? This one or this one? Well, on the red hyperbola, x equals 0 right here, at this point, and at this point. There are 2 points where x equals 0. So this red one is not the hyperbola. The blue one is the hyperbola. Okay, now the blue one has y equal to 0, but that's just fine. If y is 0, then this thing is 0 here. And we have x squared over a squared equals 1. Well, that's all right. Matter of fact, x squared over a squared equals 1 means, as we saw before, that x is either plus or minus a. And if x is plus or minus a, that means we either have the point a0 or negative a0, since we got that by assuming y was 0. So if y is 0, x is plus or minus a, giving us a0 or negative a0, consistent with the blue hyperbola. Similarly, if we have the red circled hyperbola here, indicated by the red graph, that comes about when we have y squared over b squared minus x squared over a squared equals 1. It's the x squared over a squared that's got the negative rather than the y squared over b squared. And in this case, the situation is reversed. Y can't equal 0 because that would mean that a negative would have to equal 1. so that we have to have an x equals 0 point. If x equals 0, then y is plus or minus b, since y squared over b squared is 1. Okay? Which means that we have the point x is 0, y is plus or minus b, 0b, or 0 negative b. So those points are also consistent with the picture, and you should understand all of that very well.